2 seconds later.
There's a major.
All right, well, hi everybody. Good evening. Thanks for coming to the June meeting of the El Segundo Historical Committee. We do these meetings and sometimes there's talks on the first Thursday of every month. So if you're interested in coming to more of these, I have a sign-up sheet in the back. If you want to put your email on the list, we'll make sure we let you know when we're having more talks. Tonight, we've got Betsy Wilson, and she is a retired telemetry engineer from JPL, and she's going to be showing some amazing photographs that were taken on the missions that she and her husband worked on. Do you want to say anything more about that?
I will.
Okay. Do we want to share anything else about the historical committee?
I'm Julie Stoller.
Yeah.
For those of you that don't know me, and Holly and I are going to be working together for the history room. And with 25 people, 30 people here tonight, and we want to come up with different presentations that people are interested in. So if you can give us some suggestions on things that you may like to hear about or learn about, Holly and I are open to receiving those suggestions, and then we can work on it from there instead of us just deciding what we're going to hear about. And we're not going to do it every meeting having a presentation, because there's some business that needs to be done. And also looking for volunteers for the history room. Right now we have 4 days, three afternoons and 1 evening that the history room is now going to be open with volunteers, so we're always looking for more. If anybody's interested, you don't have to be from here, you don't have to have been, an old timer from 1910 to work up there. Just somebody interested in history, somebody interested in keeping things going, and there's small projects that can be done. You can bring a book and read it, but it's nice to meet the people that are coming in for the first time to maybe see the history room and see what's in there. So if you're interested, let me or Holly know, and we would be glad to add you to our calendar. And it's very open on when it is that you would like to volunteer, but if you could give 2 hours, would be great. Thank you.
Yeah, that would be amazing. It's also a great opportunity if you are interested in looking at things in the history room. If you volunteer, you get to sit there and look at the stuff in the room. You can take down a photo album and look through it and explore the things in the history room while you kind of babysit the room while other people come in and explore as well.
Yeah, there's a lot of rabbit holes to go down when you're in there.
There's all kinds of fun stuff to look at.
I go down these rabbit holes, so it's fun to work in there. It's not like drudgery to have to sit there. It's fun to work in there and just kind of make up your own thing to do.
Yeah. So if you would have anything that you would like to maybe present on, or if you know somebody who might want to present on something, let us know. And once again, if you have a topic that you want us to research, that you want us to put on a presentation about, you can let us know too. So you can either talk to either one of us, or you can even write it on the sign-in sheet in the back, or you can send us an email. I have an email address, I think.
90245history@gmail is our new email address.
And if you want to sign up to get reminders about these events coming up, you can add your email address to our paper in the back as well. All right, I think we're gonna get started. Do you have one question here before we get started? What's up?
I know who would want to be at the history thing.
Okay.
Snakes.
Who was it?
Snakes.
Snakes. Okay.
Well,
the dunes up there. We had somebody discover that we've got legless lizards up there. People thought they were snakes for a really long time, but it turns out they were legless lizards, and we could probably do something about that.
Also, wait.
All right, we gotta get started though, so that we can get out of here in time.
Okay,
We'll have time for more questions later, okay? Okay. We gotta get started. Betsy's got a great presentation she wants to start here.
So, can you all hear me later? Okay. Okay. So, first of all, this is my favorite picture, and I'm going to talk about it in a little bit. First, I want to thank Holly and Braz for their unflagging technical and mental support. And on my last slide, I have the URLs of where you can find these pictures and my email. And there's a handout up here that has the magic numbers to get to these pictures once you get to that site. if you have questions, ask them anytime. If they're about a particular picture, you should ask them when we're on that picture. Just, you're gonna have to catch my attention, cause I'm gonna kinda be up there with my notes and work in the computer. Okay, so, and what I want you to take away from here is just appreciation of the variety and beauty and how different it all is. So I'm only gonna talk about those three subjects, geysers, rings, and lakes, not in that order. Okay, so this is my favorite picture. I'm gonna use these pointers. For one, it's taken, oh yeah, here goes the light, so you'll see this better.
We got a little bit of.
Yeah, that's good. This picture was taken from the shadow, from in the shadow of Saturn, right? Which is why it looks a little weird. You can't really see much of Saturn itself. On the bottom of Saturn, you see the reflection of the rings. Okay? This is the sun just peeking through what they would call on a moon eclipse, the diamond ring effect. So that's one. We're going to talk later about this ghostly looking, very diffuse ring, which was only recently discovered. And we're going to talk about this little tiny ring here. And now, right up there, I don't know if you can see that dot.
Oh, there it is.
No, that dot is Earth. That is Earth, about 1 billion miles away, almost 1 billion miles away. So, this is how the talk got started. This is my hallway. My husband's in my hallway where we put up, when we moved in, our favorite pictures and posters. And so when people come over, they like to look at it, and I tell them about things. And so one thing led to another, and finally, here I am. So we're going to start with lakes because it's the shortest subject. All right. This is Saturn's moon Titan. This is what it looks like in true color. It's got an atmosphere. That's why it's so featureless. It has a very thick, very dense atmosphere. So when we sent the spacecraft Cassini to the Saturn system, one of its big objectives was to look at Titan. When Cassini got close, it could see a little better, and it saw some surface variability, and down on the bottom right are clouds, actual clouds. So Cassini was sent with a probe or a lander that was going to come off, that did come off the spacecraft and go down and land. It wasn't a rover, but it was a lander, and it landed on the surface of Titan, and it parachuted down, and it took pictures all the way down. And this is one of the pictures it took on the way down, and you can see that there's what looks like channels, river channels, little streams emptying into bigger streams, and finally it ends up at this very flat thing here. So Titan and Earth are the only bodies in the solar system that we know of that actually have a liquid cycle. But on Titan, the surface is minus 290 degrees Fahrenheit. Water is a rock on Titan, just like rocks here. So what is that liquid? It's methane and ethane. That's what's up in the clouds, that's what's coming down as rain, that's what's going through these channels, and that's what's in these lakes and seas. So when we landed on on Titan, this was the view from the lander. They built the lander in case it landed on liquid, but it didn't. It landed on what they finally decided was sort of slushy sand, sort of marshy. So these rocks could be water rocks. These ones that look really big is because they're close, so it's all sort of foreshortened, and we don't really know what those rocks were, but we did not see liquid there. So how did we see liquid? Well, they knew they wanted to see through those clouds, so they equipped the Cassini spacecraft, not this lander, but the spacecraft, with radar. And radar can see through clouds, not with the visible light. And this is what the radar saw. So this is not true color. This is from radar only. So the black is the liquid. The black is a lake. The blue around it is the slushy areas, and the tan and brown are just the rocky surface. So that's one swath of radar. But if you look down from the whole northern hemisphere of Titan, of course it put a lot of these together, and where it's white, they just didn't have data. And you can see that there's not only these really big ones, but there's a lot of little tiny ones, which is probably what was in that other swath. The biggest one is bigger than our Lake Superior, just to give you an idea of the size.
Hey, Betsy.
Yes,
How big is Titan in comparison to Earth?
it's bigger than our moon, but not nearly as big as Earth, but I don't know the actual numbers. So that's it for lakes, because that's the only other thing besides Earth that has lakes.
Does that yellow circle cover the whole planet, or about half the planet?
Half of it.
Okay.
The northern hemisphere only, and I guess it's kind of squashed together on the side, but there's some stuff going on there too.
That makes sense.
So, yeah, because this, you can see these lines, that's not really on Titan, right? But they converge right here at Titan's North Pole, which is its rotational axis. They did get radar on the South Pole, but the lakes are concentrated towards the north. Do they know why? No, I don't think so. Okay, so now we're going to go on to the geysers or volcanoes. Yes.
Is that, does, Titan have more, water than Earth? More lakes than Earth?
Ah, that's a good question. Well, it might, but it doesn't have oceans. So if you count oceans, Earth has a lot more water on its surface than Titan has liquid on its surface. But as far as Earth lakes, I couldn't actually answer that question. There's going to be a lot of me up here saying I can't answer that question, just so as you know. All right, so we're going to go on to geysers or volcanoes or things erupting, and this,
Betsy, was that water liquid?
that's methane, and it's liquid. You know, methane on Earth is a gas, but if it gets cold enough, like on Titan, it's a liquid.
And is that methane what caused the rivets, the rivulets?
Yes,
Yeah.
it rains, they think, and, you know, it rains and it runs down the rocky surface and goes into the lakes. Right, that's what makes those channels. And there's actually pictures of those lakes rising and falling. So they can see that, yeah, the level is changing. So this was the very first picture where someone looked at Jupiter's moon Io and said, oh, look, there's an eruption. Who knew? And so that's right here. So, and now I have to give you a couple of words. So the edge of a body is called the limb, but the day-night line is called the terminator. Somebody used that word terminator a couple other times, just so as you know. So the other thing was, here's something on the night side, but it's high up and it's catching the sun. So this was the very first discovery. This geyser here, well, it's really a volcano, is about 150 miles high.
Woo.
So it tells you how big the moon is, not very big. But here it is. This was taken by the Galileo spacecraft as it toured the Jupiter system. This is a true color picture. This volcano is about 100 miles high, but they have some ones that are up to 300 miles high. So all of this yellowish, orangish stuff, because what's coming out is sulfur compounds, which is yellow. And so that's why it all looks very yellow. It was dubbed pizza face, once they really knew what it looked like. And the black is either a current, all these old black dots, those are either current or former volcanoes. You know, I don't know the difference between a volcano and a geyser because it's all just stuff erupting. So here is a close-up of one of the eruptions. This was seen first by Voyager 1 in 1979, and it has been visible in every single picture ever taken of this spot ever since. So you can see these sort of plumes that point to the inside, and that's pointing right to the point of the eruption, but this is sort of smoky stuff. Smoky stuff just curling out of it. Now there is, at any one time, there might be about 400 of these eruptions on Io, and this is what it looks like in infrared. So infrared is the light that shows heat. If you're not familiar with the electromagnetic spectrum, if you've ever seen an infrared camera, you know, like your mouth and your eyes look white and the rest of you looks darker. So the hot spots are the volcanoes, and there's an awful lot of them, and this is just one side. But Io is not the only moon where there are these eruptions.
What does IO stand for?
That's it.
Oh.
All of these names were, every planetary system has a system of names for its moons. And so Jupiter's are mythological, I forget what, that are affiliated with the god Jupiter.
Why was
This is a,
What? Go ahead.
why was Ion so, why was it so dirty?
Why is what so dirty? Io?
Why did Io look so dirty?
Well, there's nothing else on it except that stuff. So if you look at a picture of Earth, it's got brown and green and, you know, it's quite mottled. So Io is the same way. Kathy?
Planet is covered in bird poop.
maybe I can tell it really fast, it's a silly story. In 1979, when they discovered this, on the news reporter said, and the scientists have discovered volcanoes on Jupiter's moon 10. Yeah. So, decided for that. I heard it. It's for real.
Okay, so moving along to Neptune's moon Triton, which was only seen very quickly by Voyager 2 in a flyby. But you can see these dark streaks all pointing in the same direction. Those are plumes from some sort of eruption. And the smoke, or whatever, the little particles, are being blown around by a very, very thin nitrogen atmosphere. That nitrogen is probably coming from these eruptions itself, but we don't know. Each of those streaks is about 100 miles.
Wow.
But the next one is the best one. So this is Saturn's moon Enceladus, and it doesn't look like much in this picture. It is the brightest object in the solar system. And if you look at it carefully, it's very smooth. It doesn't have a lot of craters. It looks like snow, which is why it's so bright. But at the bottom are what were dubbed tiger stripes. And they are considerably warmer than the rest of it. So what's going on there?
Is that blue a real color?
Yes.
Okay.
These are what's coming out of those tiger stripes. So you can see here's one, here's another there, there's one behind the horizon. There's really quite a few of them, and they are spewing out mostly water, a little salt, molecular hydrogen, some volatiles. So this is an ice world over an ocean that has cracks in it, and it's spewing this stuff out. So now I have to talk about backlighting, which was the same as that first picture that was taken in the shadow. So photographers are familiar with backlighting, sometimes called forward scattering, or the scientists call it a low phase angle. You know it because if you're driving around at noon, your windshield looks really clean. If you're driving into the setting sun, you see every little speck of dust on your windshield. That is backlighting or low phase angle, and that is gonna play a big role in some of these pictures because that's what shows all these little tiny particles. So these two pictures show the extent. So on the picture on the right, that's like what you would see. But on the left, every different size of particle has been assigned a color. And so you can see how far out they are really coming out of this little moon, circling Saturn, right? Some of the particles fall back and it causes that snowy look, and that's why you don't see craters, because they're continually getting filled in. But what happens to those particles that are escaping the gravity of Enceladus? It's making a ring. There is Enceladus in the E ring, and E does not stand for Enceladus, but anyway, there is Enceladus in the E ring. Now you can see it, that little tiny black dot is the moon. Once again, this is backlit, so the sun is on the other side. So the black dot is the shadow side of Enceladus. The bright white underneath it is the current plume, and everything else here is all those little particles that have just made their own orbit and made their own ring. So back to this picture, this is that ring. This is that ghostly ring, which we didn't know about till we got there because we couldn't see it from here because it wasn't backlit. So now we're going to go, so Saturn is not the only planet that has rings. In fact, all 4 of the outer planets, all of which are gas giants, have rings. So this is Jupiter's ring. Jupiter really has a complicated ring system, but it's very small. It's kind of thin. But what I want you to notice is that even though this looks very thin, you can see it's got some fuzzy around it. But on the bottom, once again, they have taken each particle size and assigned it a color. And you can see that it's really got a lot of vertical stuff. It's just not obvious in visible light. Did you have a question?
Yeah. How are the rings created?
How are the rings created? Well, normally they think like the Saturn's rings were probably created by hunks of ice being broken up, and then as they're broken up, they're circling just like their parent was. However, the one I just showed you makes its own ring because it's ice particles coming out. But the real answer is they don't actually know.
And
Different ones are created differently, and the very last one is going to be very interesting because they know how that one was made.
and also there's this app, and it's on the weight. It says the weight is different for the planet, and I think you'd weigh more the bigger and heavier the planet is, but the one planet that really made a difference was Jupiter. And why didn't the other big planets make a big difference?
Well, you're absolutely right. The larger the body, the stronger the gravity, and then the more you would weigh if you were standing on the planet. Of course, on Jupiter and these other gas giants, you can't stand on them because they're gassy and they're not solid, right? Did that answer your question?
Do we know why they aren't becoming solid, why they remain gas?
Why? No, I don't think that there's an actual why to it. That's just the way they are.
At this point?
I mean, in other planetary systems, they have seen very large rocky planets, and they've seen small gaseous planets. They think Jupiter is almost like a failed star, but it's not big enough to actually be a star. But it's what kind of is a proto-star. Okay, so that's Jupiter's ring. We're not going to spend too long on it. This is Uranus's rings. So Uranus really has what they counted as 13 rings, but I can't differentiate them on this picture. It's very dark out there because, for one, the particles themselves are dark, and for two, you're really far from the sun. Only Voyager 2 has ever seen these, because it's the only spacecraft that has been by this planet. and it had to take a very long exposure. So these streaks are stars that just smeared during the long exposure because the exposure was really trying to get the rings. And once again, this is backlit, so you can see these.
So when were these rings discovered on the ring?
Pardon me?
When were the rings discovered?
I think they were seen to some extent before Voyager 2 got there, but they weren't seen well. Now that they know to look for them, there's a lot more pictures. I know there's been pictures of Hubble, but none of them see them in this great of a resolution, in this detail. And so last, not quite least, is Neptune. Neptune has 5 rings. Again, it's very, very dark. So what's interesting here is you have a bright ring and you have a bright ring, but there's stuff in between them. So they're not quite as separate as you might think. All of these dots on the picture, it was so dark and they wanted to see them so well that they not only left all the stars in the background, but when you have a camera out in space, various things will impact it and make a little pixel-sized block. And they left all those in here too because they didn't want to take them out because they wanted to see every single thing they possibly could. But Neptune is a complex system, and we're going to see another one of it.
Excuse me?
Yes.
Why are there spaces in between the rings?
Why are there spaces in between?
Yeah.
That's just the way it happened. They're not all like that. So we're going to see some that don't have a lot of space in between that actually have some thickness to them, Saturns. But you know, as the particles or the boulders or the rocks or whatever size they might be, as they orbit around the planet, they hit each other and they break up. And then they attract each other and they glide together again. So they're constantly changing, and so they're constantly breaking up, and that's what makes a lot of these small particles.
And what's in the spaces?
What's in the spaces?
Yeah. Just rocks?
Oh, you mean what's in the rings?
There's spaces between the rings.
Well, so in this picture, there are particles. That's why it's showing you that there's actually light, but there can be nothing in between, and that's why they look like gaps. And I'm going to show you some gaps very soon. So back to Neptune. So this is a clumpy ring of Neptune. So it was so dark, they really had, this is Neptune here, they had to really overexpose Neptune. This is the terminator of Neptune, and this is a diffuse inner ring, and here's a clumpy outer ring. So we don't know a lot about all of these other rings because, like I said, only Voyager 2 ever saw them. So now we're going to go to the Lord of the Rings, Saturn, and we're going to see something that doesn't look very ring-like yet. I got ahead of myself. This is Saturn's A ring, and this is an artifact, a phenomenon called a propeller. So it's the same one. On the top picture, you're looking down on the sunlit side of the ring, and on the bottom picture, you're looking up at the shadow side of the ring. So it's a little tiny moonlet. You probably, mostly that's reflection right in the middle, and it both attracts and repels particles. It's clearing a path in the rings. So this is how moons get started. These propellers, there's quite a few of them in the rings, not just this one, and they're permanent. They stay there as long as they've seen. In the bottom, when you're looking up from the dark side, it's black because it's dense and there's no sunlight coming through, and it's so dense that there's no forward scattering even. I have to say, one of the things I didn't say in my introduction was, this is why I needed my notes. I have up here a handout, and it gives you, I told you about that. It gives you the number to look these up. And when you look them up, you'll come upon the caption, which is a paragraph or 2 or 3 written about them. And this has a really good explanatory caption. Okay, so now, and this is one of my favorites, Daphnis the Wave Maker. Daphnis, a moon, has made this gap in the A ring that's called the Keeler gap. But the interesting thing is these waves. So this is the inner part and this is the outer part. So the inner part moves faster than the outer part. So as the inner part passes Daphnis, Daphnis is pulling particles towards it, and as Daphnis passes the outer part, it's also pulling stuff towards it. And the reason that it's getting so close is that Daphnis is on an inclined orbit, so it's not orbiting exactly in the same plane as this ring, as the A ring. So when it passes through on its inclined orbit, this is when it makes these perturbations, which are both horizontal and vertical. Yes?
Why is it wavy?
Why is it wavy? Because they are attracted by this moon. The moon has a little tiny bit of gravity. Everything has gravity. The moon has a little tiny bit of gravity, and so these particles are attracted to it. You're going to see more in a moment.
And what's that dot?
This dot is the moon Daphnis, and here it is, close up. You can even see some stuff on it. So this is about 4.3 miles. It's one of the few numbers that I know. I'm very proud of knowing. And here is a little stream of particles heading towards Daphnis. Now, the gap is not this small. This picture was taken at an angle, and so the gap looks a lot smaller than it really is. But this is going to show you, this is also Daphnis, the vertical extent, because as I said, it's inclined, so the perturbations on the sides are both vertical and horizontal. So here they are catching the sun, right? This is the inner one, so it has passed Daphnis, and this is the outer one, so Daphnis has passed it. Here, this picture was taken really close, like within a week or two, I think, of the equinox, when the rings are edge on to the sun, and therefore things cast shadows. And so from these shadows, you can see how tall that is. I don't think I have anything about actually how tall that is. And here's the moon itself casting a shadow. There is, which I don't have the picture of because it got really long, but some edges of some of the rings also have a lot of perturbations in the vertical. The rings themselves are quite thin, but these perturbations can be several miles. Did you have a question?
Yeah, how, do you know, did you hear anything about whether it was hard to get the satellite to take that picture? Because that shadow might have changed height pretty fast.
It didn't change height too quickly because Saturn is not tilting very quickly relative to the sun, but the Cassini spacecraft is moving quite quickly. However, they knew the equinox was coming. I mean, they know exactly what's what at all times, and so they plan very carefully to take these pictures. And so I'm sure this picture got planned months, if not years, in advance.
That's a good one. Thanks.
Yes.
How does the ring, are the rings of Saturn made out of gas?
No, they're ice mostly. They're almost all icy particles.
But what about Jupiter? Are its rings made out of gas?
No, they're also ice. They're pretty much all icy rings. They can be a little rocky also, and we'll see one of those. So, another interesting thing. This is Saturn's moon Prometheus, and I've blown it up top. And the F ring. So this is the moon Prometheus. Okay, it's 53 miles long. Prometheus is 53 miles. So Prometheus orbits at a slightly different orbit, a more eccentric orbit, so that is to say a more oval kind of orbit, as opposed to the circular orbit of the F ring. So once every orbit, it just plows right through the F ring, and it attracts and repels particles on its way through, and that's what makes these channels. Once every orbit, which is like, I don't know, 14 something hours, you can see these channels made. And again, the F ring is actually, I think, 3 or 4 different rings with some diffuse stuff on the outside. And here we have it again. So here's Prometheus. Here's the A ring here. And so this is the most recent channel, an older one and a much older one. And so by the separation on the channel of the 3 different rings that make up the F ring, you can see how they have moved relative to each other. And so what that ends up doing, which I don't have a picture in here of, it makes some very chaotic parts of the F ring. It gets to be really complex. Okay, and another ring and a moon. This is the moon Pan, and it is about 22 by 14 miles, and you see that it has accreted stuff here around its equator, and this is it. This is in the Encke gap, and it has cleared this gap itself, except for a clumpy ring here. And these are the clumpy rings in that same gap. So Pan is not in this picture, but for some reason, it has left behind these trails in there.
A
So-
question, Betsy.
Yes.
Does the moon, do these little moons, do they stay in a concentric orbit with the rings?
Yes, but some of them are in a slightly more inclined orbit, and some of them are in a more eccentric orbit, but they're all orbiting in the same direction and roughly in the same plane, with one exception that we're gonna see at the very end.
So most of these moons seem to be more potato shaped than our classic
Yes.
spherical moon.
Well, they're not nearly as big, and so gravity has not pulled them into a sphere. You have to be really, really big for gravity to pull you into a sphere. I think even the second largest asteroid is not even quite spherical, and it's, I don't know, a couple thousand miles in diameter. So yeah, well, plus these moons are constantly getting stuff added to them and taken away and getting hit by pieces of ice, so they're always changing. So here is, which you can see on previous pictures, but I want to point out that not only are there waves on this edge, but these lines are what are called spiral density waves. So where it's lighter, the rings are thicker, and they move like a vinyl record, right? They're just spiraling in, and that's caused by gravitational interactions both with Pan in this particular gap and other moons. And here is one more odd thing. So you can see these horizontal streaks. These were first discovered by Voyager 1 as it flew by, and they call these spokes. And there's still a little bit of a mystery, but they seem to form when the ring exits the shadow of Saturn and gets out into the sunlight. They're very, very fine particles above the plane. And they think, but as far as I know, it's not known yet, that they are caused by electromagnetic repulsion and attraction and interactions with Saturn's very strong magnetic field. So these spokes remain all the way around until they get back into the shadow, and then they change or go away. But there have been spokes. Now that they know to look for them, they see them all the time. So here is this little tiny ring that you saw on my favorite picture. This is the moon Aegean is not here, but the moon Aegean. If someone knows Greek, you might think I'm mispronouncing that, because I don't really know how to pronounce that. Does everybody think it's Aegean?
Yes.
Okay. So, because it's not spelled quite like the Aegean Sea, right? So, okay, so anyway, it's a tiny little ring and it's very bright on the inside, but it's very diffuse on the outside. So I just like it because it's very, very pretty. And this is what's called the G ring. And by the way, the rings are not named in order of their distance from the planet. They're named in the order in which they were discovered. So they're not in alphabetical order, which makes it a little difficult. Okay, so now the biggest for the last. We're almost done here. So this is not a picture. This is an illustration, but I am going to show you a little picture. So this Saturn system is about 250,000 miles. Okay, if you took the whole Saturn system and you put it in this little tiny circle there, this is called the Phoebe ring, and this is caused by a moon of Saturn called Phoebe. It's a fairly large moon. It's not at all circular, and I didn't put up a picture of it because this isn't to talk about moons, but this is an artist's conception, and they didn't even know about this ring at all ever until the Spitzer spacecraft, which is an infrared telescope, saw this, like out in the middle of nowhere practically, and they thought, oh my goodness, there's a ring around Saturn, but it's really big. So again, here's your 250,000 mile Saturn in the middle of this, and this ring is, let's see, it's several million miles wide, and it's 7-something million miles away from the planet. So it's an absolutely huge ring. So the moon Phoebe, they think what has caused this is that the moon Phoebe gets hit by whatever's passing through space. Of course, we're all getting bombarded all the time. That's what meteors are all about, or meteorites. And so Phoebe just sheds this stuff. Now this ring goes in the opposite direction from all the other rings, and it's highly inclined, which was the point of showing Saturn at an angle, right? And on the previous picture, you can see the ring's at an angle and Saturn's flat, and here Saturn's at an angle and the ring's flat, so whichever way you want to see it. And this was the only picture ever taken of that. So that was the biggest for last, and there you have it. If you want to, that information is on the handout, and there's only like 25 handouts.
I can make more if anybody wants.
But you can take a picture of that, and if you get the handout, it's got a thumbnail of each of the little pictures with the PIA and the 5-digit number, and it is all 8 of those that you have to put into either a search engine or on either one of those sites, and it will take you right to that picture. And other related pictures also, and it has a caption to tell you all about it. There's my email. And that's that. Thank you very much.
So, maybe they start like doing the photos. How long ago did they start getting all these photos?
Well, the earliest one from here is Voyager 1, but I mean, ever since we've had satellites go up, they've had cameras. Right, so of these sets, the earliest
like
picture.
50 years?
Yeah, well, Voyager 1 was launched in, got to Jupiter in 79, but, you know, we were on the moon taking pictures years before that. So I think that the Explorer, which went in 58 or something like that, that didn't have a camera. But they had cameras very shortly after that. It was the early digital cameras, really. Any other questions? My favorite questioner, yes.
You know how at the beginning you said there was like things you could look at? You know how you, like,
The website, that's the website. We can take a look at it.
Yes, take one of
Pictures
these.
for yourself.
go to that place, and you can also, in either one of those, just type in the name of something, right? You can type in the specific picture, but you can also just type in like I-O, and you'll get pictures of that moon, right?
Not yet.
Yeah. Not 10. Okay, thank you for coming.
Once again, thank you so much, Betsy Wilson.